Greetings, ladies and gentlemen, and welcome to our Big Ideas Lesson 7.4 extension, page 316 for the 8th General, and Lesson 14.4 extension, page 654 for the 7th Accelerated. We're continuing with our real numbers lesson, and this time we're going to apply what we learned to write repeating decimals as fractions or mixed numbers. Our essential question: how can you write a repeating decimal as a fraction or a mixed number? So the first thing I'm going to do is I'm going to stop and pause here for a second. I want you to listen very closely. This is definitely one of those videos where you want to put your pen, your pencil, your marker down. You want that on your table. You want to give your full attention. You want to be looking at the screen. You want to be listening to what I'm saying. You want to be absorbing what's going on without having to write. You're going to look, listen, and learn. You're going to be learning as you're listening and looking with your pen, your pencil down. And then when I finish going over that example, then stop me from talking. Pause that video. Pick up that pen, pencil, marker, and then write it all down. And as you're writing it all down, you're processing in your brain exactly what you saw me do, and you're repeating in your head what I was saying as you're writing it down, as you're going. This might add a few minutes to the length of the video for you. It is what it is, because unfortunately, this particular video, it is 100% procedural. It is absolutely procedural. There are steps, you follow them, and that's how you do it. Not the greatest, but it is what it is. We need to review it, we need to understand it, we need to learn it, so we're just going to do it. That being said, ladies and gentlemen, before you start this video, you should have had those procedures, those steps written down by going to the top of page 316 or 654, and you wrote down these procedures, these steps, because that will help you. If you had that done before you started the video, then great. If not, you better pause and get it written down. But we're going to write these repeating decimals as fractions. So the first thing you're going to do is let x equal the repeating decimal d. We're going to write the equation x equals d. That's step one. Step two, you're going to multiply each side of the equation by 10 to the n to form a new equation, where n is the number of repeating digits. So you got to look at that decimal. How many digits are repeating? That's the power of 10 that you multiply by that equation that you wrote in step one. Step three, you're then going to subtract the equation from step one, the original equation, from the equation in step two, the new equation. And then you're going to solve for x. So hopefully you have that written down. Let's go to our first example, and let's just get writing right along, writing these repeating decimals as fractions in simplest form. So ladies and gentlemen, our first repeating decimal, example number one, is 0.5 repeating. We know it repeats forever, indefinitely, because there's a bar over it. That means, since it's a repeating decimal, that this is a rational number. It doesn't terminate, however, it does repeat. So here we go. I'm just going to write them out one at a time. Step one, we're going to write the equation x equals that repeating decimal, 0.5. So that's simple. Step two, we're going to multiply that equation, x equals 0.5, by 10 raised to the power of the number of digits that repeat. In this particular case, only one. So multiplying it by 10 to the first power means multiplying it by 10. So 10 times x is 10x, equals 10 times 0.5 is 5.5. That's what we're going to do. We're putting that decimal on the end. Alrighty. Because remember, that 0.5, I could put as many 5s after as I want. So I've got to put that decimal 5 on there. Then I go to step 3. Step 3 says I'm going to take the new equation, 10x equals 5.5, and I'm going to subtract the original one, x equals 0.5. When I subtract them, I get 9x equals 5. And the last step, 4, says solve for x. To solve for x, I divide by 9, so x equals 5/9. 5/9 is the fraction that gives me a repeating decimal of 0.5. And if you don't believe me, you take your calculator, you divide 5 by 9, and you will get 0.5555555 until the screen runs out. It'll probably round that last number on the screen to 6, but it still is a repeating decimal of 0.5. Now you want to pick up that pen marker and you want to write all this down before you go on to see the next example. So example number 2, we have 1.7 repeating. So in this particular case, once again, step 1, write x equals that repeating decimal, 1.7. Step 2, multiplying by 10 raised to the power of the number of repeating digits. And again, only one digit repeats, so it's 10 times x equals 1.7, which gives us 10x equals 17.7. Step 3, we're going to subtract them. I'm going to take that new equation, 10x equals 17.7, and I am going to subtract the original x equals 1.7, and my resulting equation is 9x equals 16. And of course, step 4, I'm going to solve for x by dividing by 9. So x equals, well, 9/16. 9 goes into 16 one time with 7 left over. So 1 7/9 is my mixed number that would give me a repeating decimal of 1.7. Pick up your pen and pencil and get busy. Example number 3. Please make sure that pen or pencil is down. Here we go. Step number 1. We have 1.41 repeating. So I'm going to write x equals, this is step 1, x equals 1.41. Step 2, multiplying by 10 to the power of the number of repeating digits. So how many digits are repeating? That's right, by 10 squared. What is 10 squared? That's right, it's 100. So 100 times x gives me 100x. And 100 times 1.41 gives me 141.41. Always want to put that repeating decimal on there. Moving right along. Part 3. Part 3, we're going to take our new equation, 100x equals 141.41, and we're going to subtract, I'm trying to use the right colors here. We're going to subtract the original of x equals 1.41, should have been in black, is what it is. Life's going to go on. And we get 99x equals 140. Step 4, solving for x means we're going to divide by 99. So x equals, we have 140 over 99. Well, 199 goes into 140 one time with 41/99 left over. So if you take 41 divided by 99, you'd get 0.41 repeating. Moving right along. Example number 4. Ooh, now we're going to the negatives. So we're going to talk about this, and you're going to have to pay attention. You better have those pens and pencils down. So we're going to go through the steps. Once again, step 1, write x equals that repeating decimal, negative 1.12. Then we're going to multiply in step 2 by a power of 10 equal to the number of digits that are repeating. How many digits repeating? That's right, 2. So we're going to take 10 squared, which is 100, and multiply it by x equals negative 1.12. And we're going to write down 100x equals negative 112.12. All right. Now, in step 3, we're going to subtract those. We're going to take 100x, not 10x, 100x equals negative 112.12. And we are going to subtract from that the x equals a negative 1.12. Now, I'm going to put that in parentheses. We've now got to remember, you've got to remember the rule of integers. It says when you're subtracting, it's same, change. We didn't pay attention to it before because we were subtracting positive numbers, which means we were adding negatives. But now, we still have that this parentheses here. That says that this x becomes negative and this 112 here, 1.12 rather, this 1.12 becomes positive. So 100 minus x is 99x again. And then a negative 112.12 plus 1.12, well, that's going to give us a negative 111. Okay? Step 4 says solve for x by dividing by 99. So x equals a negative 111 99ths. Well, 99 does go on 111 one time. So negative 1 and that's 12 99ths. Well, 12/99 does simplify. I can divide both by 3, so this becomes a -1 and 4/33. If you take 4 and divide it by 33, you will get 0.12 repeating over and over and over again. Go ahead, pause the video and write this down and then put it down and join me for the next video. Or next video. Hello, the next example. Ladies and gentlemen, our next example. 0.46 with only the 6 repeating. Oh, well, guess what? We follow the same process, ladies and gentlemen, so let's just do it, going right along. Step 1, x equals 0.46. Step 2 says multiply by a power of 10 equivalent to the number of digits that are repeating. Well, how many digits are repeating? Yes, there's only 1 digit repeating. So we're only multiplying by 10 to the 1, which is 10. So now we get 10x equals 4.66. We're just going to keep that repeating decimal 2 places because we're going to have to subtract 2 places. So in step 3, we're going to take our new equation, 10x equals 4.66. And we're going to subtract that original one, x equals 0.46. Well, 10 minus 1 is 9x. 9x, and 4.66 minus 0.66 happens to be 4.2. Now we're going to divide by 9. Oops, I almost forgot. Step 4, divide by 9 to solve for x. So x equals 4.2 over 9. Ladies and gentlemen, we don't want a decimal in there. It's not going to work for us. So I got to turn 4.2 into a whole number by multiplying it by something and writing an equivalent fraction. Well, I know that 2 times 5 is 10, so I'm actually going to multiply by 5. Multiplying by 5 will give me 21 over 45. Because 4.2 times 5 is 21, 9 times 5 is 45. And of course, 21 over 45 does simplify. Dividing by 3, I would get 7/15. And again, if you take 7 and divide it by 15, you would get 0.466666666 repeating. Our last example, ladies and gentlemen, I think in your insert, I put down example 5 one more time. So you got to scratch that out and write this one down, -0.23. -0.23 is the correct 6th example. So we're not doing the same one twice. So once again, follow along. The pens and pencils are down as you're following along with each step, saying them in your head with me as I'm walking through it. You can say it with me as I'm walking through it. You can have your notes in front of you to the front page, going through each step as I'm going through them. And then at the end, you'll pick up your pen. So x equals -0.23. Multiplying that by 10. Well, again, how many digits are repeating? So 1, so we are multiplying by a power of 10 to the 1 times x equals -0.23. And so our result would be 10x equals -2.33. All right, now we're going on to step 3, and we're taking that new one, 10x equals -2.33, and we are subtracting our original one, x equals -0.23. So again, it's in parentheses. You got to remember, same change. This x becomes negative, and this 0.23 becomes positive. So you have 10x plus a negative x. That gives me 9x. And you have a -2.33 plus 0.23, and that would give you a -2.1. In step 4, we're going to solve for x by dividing by 9. So x equals a -2.1 over 9. Well, once again, we don't want that decimal in there. So what can I multiply that 0.1 by to get a whole number? That's right, we're going to multiply by 10, both numbers. And we're going to get a result of -21 over 90. And if you then simplify that, you get a -7 over 30 by dividing by 3. And of course, a negative 7 divided by 30 will give you a negative 0.2 with a bunch of repeating 3's. Ladies and gentlemen, pick up your pencil, write that down, and then when you have that written down, forward to your quick write. Here's your 2 quick writes, writing these 2 decimals as repeating, these repeating decimals as fractions. 2 examples, ladies and gentlemen, and when you're done with that, you're done with your notes tonight. Thank you so very much for joining me. I know it was a little bit longer, but it was one video, and you got it, and we'll talk about it. Come to class with questions. You rock. Can't wait to see you.